Here's an integral we need to calculate. It's a definite integral. We've got between 0.2 and 0.5, so there'll be no plus c. And straight away we see that we've got a fraction going on here, so we've got to actually split it into its partial fractions. So if we just look at the 1 over q squared outside of 1 minus q. Now the rule for splitting it up into its partial fractions, it'll be something over q, and that's something we'll call a. Now we've got a repeated factor, we've got q squared, so it'll be another something which we'll call b over q squared. And then we've got another factor of 1 minus q, and we'll call that c. Now if we were going to add all those, we need to make the denominators the same. So the first one would be q. Now what have we got to multiply the denominator here by to get q squared outside of 1 minus q? Well, we'll have to multiply by q outside of 1 minus q, and that will give us a denominator of q squared outside of 1 minus q. So whatever we multiply the denominator by, we're going to multiply the numerator, so q outside of 1 minus q. So there's my first one, plus second fraction is just b over q squared. Now what have we got to multiply b? What are we going to multiply q squared by to get this denominator? We're going to multiply top and bottom by 1 minus q. And the last one is c over 1 minus q. What have we got to multiply the denominator here by to get q squared outside of 1 minus q? We're just going to multiply top and bottom by q squared. And what that has done is just made all the denominators the same, then we can combine them together. Okay, now once again, this sort of work has been covered previously as to how to find a, b and c. We basically just equate once we've got this as a single fraction, we then equate the numerators, so we can say 1, and by letting q equal different values, we can eliminate some of the terms with b and c, etc., and get a, and then get b, and then get c. So I'll just abbreviate this, and when you do go through all that, you'll get a, b and c all equal to a value of 1. So therefore my integral of 1 over q squared outside of 1 minus q. So that integral will be equal to, now if a is equal to 1, it'll be the integral of 1 on q dq, plus the integral b is also equal to 1, so it'll be 1 over q squared dq, and c is equal to 1 as well, so it'll be the integral of 1 over 1 minus q dq. And I'm not so much interested at this stage, I just want to get the limits of 0.2 and 0.5. I'm just going to find out what this integral is first. Now the first one's straightforward. 1 on q is just ln of q. We'll do the absolute value of that. Now 1 on q squared, 1 on q squared can be written excuse me, as q to the minus 2, and the rule when it's not to the minus 1, obviously q to the minus 1 is ln q, but when we've got q to the minus 2 we add a power on the power, so it'll be plus, we add a power, q to the minus 1, and then we put it over that new power. So we've integrated that. If it was q minus 1, it would be just ln q minus 1. But because we've got 1 minus q, it's not that easy. What we've got to do here is to make it into q minus 1 by multiplying top and bottom by -1. So that'll be the integral. If I multiply the top by -1, I get -1. And multiply the top bottom by -1, I get -1 plus q. Now I can write that as q minus 1 dq. And now we can pretty this up a little bit, and so that's ln, the absolute value of q. Now that -1 will make that plus into a negative 1 on q. Don't forget q to the minus 1 is 1 on q. The negative makes it into a positive there. And the negative can come out the front, minus ln q minus 1. Now there'll be a plus c here. But now we're going to find what we're after. So we've got the integral, it'll be 2.5. The original question was 2.5. The integral between 0.2 and 0.5 of 1 over q squared outside of 1 minus q dq is equal to 2.5. Now we've just above calculated what this integral is, and it's ln q minus 1 on q minus ln absolute value of q minus 1, and that's between the bounds of 0.2 and 0.5. So that's equal to 2.5. We can now do a substitution in. We'll put 0.5 in first, so that'll be ln of the absolute value of 0.5 minus 1 over 0.5. So we're putting in 0.5 first, minus ln 0.5 minus 1. Now that's just substituting in 0.5, so we need to put a bracket around that. And it'll be minus, and we put in 0.2. So it'll be ln 0.2 minus 1 over 0.2 minus ln 0.2 minus 1. Close that bracket and then close the square bracket, because 2.5 will have to be multiplied by the entire answer then. Okay. 2.5 ln of, we can drop the absolute because it's already plus 0.5, 0.5, so that'll be ln of 0.5. 1 over 0.5 is 1 divided by a half, which is 2, so that's minus 2. Now the ln of 0.5 minus 1, 0.5 minus 1 is negative 0.5. That's the absolute value, so it'll be just minus ln of 0.5 minus ln of 0.2. Now 1 over 0.2 is equal to the number 5. It's a minus minus, so it'll be plus 5. And then minus, once again we've got a minus minus, so it'll be a plus ln. 0.2 minus 1 is minus 0.8. That's the absolute value, so it'll be just ln of 0.8. That now will be equal to 2.5 ln of 0.5 minus ln of is equal to 0. Negative 2 plus 5 is equal to 3. And then you've got plus ln 0.8 minus ln of 0.2. Now when you are subtracting logs, you are actually dividing the numbers. So that'll be plus ln of 0.8 over 0.2. 2.5, 3. How do we work this out? The easiest way is just to multiply top and bottom. Just make the denominator a whole number. So to make the denominator a whole number, we've got to multiply that by 10. Whatever you do to the bottom, you've got to do to the top. So that'll be just equal to 8 over 2. And so that'll be plus ln 8 over 2 is just 4. And there is your answer. So just in summary there, we've actually got a definite integral here that we need to be able to calculate. We're going to use partial fractions to do the integration first up. We find our a, b and c in the normal methods of equating numerators left and right. We then do the integration in terms of q. Then we go back and substitute in the original integral that we're asked to find between 0.2 and 0.5. Be very careful of signs. When you've got that negative out there, we know that it's going to change these negatives into positives. So we remove the brackets, collect all your like terms, and then, because it is a course that you don't use calculators with, we just simplify it as much as possible.